We'll see the velocity modulation process in the two cavity klystron today. So we see it here that the cathode has been placed with the negative potential and anode has been placed at minus negative potential, but this minus Vg is less than V naught, and the magnitude of this RF voltage, that also is less than this beam voltage. Here the collector has been placed at positive potential and the input cavity has been placed at ground potential. Here we have drawn the scale of distance and the time scale for the electrons movement, and the distance has been shown between the gap, that is D, and here from this place to this place, that is L distance has been placed, that is drift space length is there. So and here this distance catcher cavity gap distance is also D, so the distance between them is same, and these catcher cavity and buncher cavity both are assumed to be of the same structure. Okay, so the characteristics and the properties will remain same for the buncher cavity and the catcher cavity. Here we assume that the cathode has been heated up by this element, heating element, and the electrons are leaving this cathode with zero velocity and moving with the V naught velocity, and they are reaching at this time t naught with the V naught velocity, and at time t naught the velocity of the electrons in the electron beam is V naught. So the energy attained by the electrons up to this time is half mv naught square, and the supplied energy to the cathode is EV naught for one electron calculation. Here V naught is equal to, we can calculate it with this formula, V naught is equal to square root of 2 EV naught by m, and where we have kept the value of E is equal to 1.6 into 10 to the power minus 19 coulomb, and m is equal to 9.1 into 10 to the power minus 31 kg. Like this it has been calculated, and it is its unit is meter per second. The input signal has been represented by the sine wave, and we are taking it Vs is equal to V1 sin omega t, where omega is the frequency of this RF input signal, and this RF input signal is to be amplified. So, and the next thing is that the time taken by the electrons to move from the first grid of the buncher cavity to the second grid of the buncher cavity is tau. We are taking T1 minus T naught is equal to tau. We are taking it. So here we have seen tau is equal to T1 minus T naught, but this tau has been calculated by assuming that this velocity of the electrons is not changing by the effect if it has not been applied. So before application of this, we are assuming that that velocity is not changing. So that is d by V naught. If at all it is changing with the effect of this RF input signal, it is not changing very large. So that variations are very small in the velocity. That we'll see that what is the velocity at this point. So that is V naught is equal to square root 2 e V naught divided by m. Whereas what will be the velocity at this point if the RF signal has been applied to the buncher cavity. So let us see that first we'll have the average of this V1 sin omega t over this duration t naught to t1. So for calculation of the average, we take the integration, that is Vs equal to 1 by tau t naught to t1 V1 sin omega t dt is equal to, if we solve this sin omega t integration is minus cos omega t by omega, where v1 is constant, so we can write it minus v1 upon omega tau cos omega t1 minus cos of omega t naught after placing the limits. So this also we can merge it into this. Now this becomes, that is cos omega t naught minus of cos omega t1. So when it becomes cos omega t1, now we'll take, that is, now what should be the average gap transit angle, in this buncher cavity. What should be the average gap transit angle? So transit angle is nothing but the theta. Omega we have taken from the input signal, and tau is the time taken by the electrons from for moving from first grid of the buncher cavity to the second grid of the buncher cavity. So we can take theta g is equal to omega tau, or theta is equal to omega t naught minus omega t1. So from this omega t1 we can calculate, here you see this formula we have written, theta g is equal to omega tau, omega t1 minus t naught, and omega d by v naught is equal to, from this we can find omega t1 is equal to omega t naught plus theta g. So in place of here, in place of omega t1 we have placed, that is omega t naught plus omega d by v naught, and omega d by v naught we are replacing it with theta g. So here it becomes v1 divided by omega tau in bracket omega t naught minus cos of omega t naught plus theta g, and here we can apply the formula cos c minus cos t. So this formula we have written for your easiness, that is cos c minus cos t is equal to 2 sin c plus d divided by 2 sin d minus c by 2. So vs is equal to v1 sin theta g by 2 divided by theta g by 2, and sin of omega t naught plus theta g by 2. This is the simplification, and this factor sin theta g by 2 by theta g by 2 is termed as input beam coupling coefficient. Here if you see the input beam coupling coefficient here of this, what is the coupling coefficient for the beam here, that is termed as input beam coupling coefficient, and the output beam coupling coefficient will be calculated here for the catcher cavity. As we have said that these both buncher cavity and the catcher cavities are same in structure, that's why their coupling coefficient will remain same. In this next step, which is, if you see, we can replace this v1 sin theta g by 2 theta g by 2 into sin omega t naught plus theta g by 2. Here we can write it, that is v1, if you see v1 beta I, we can replace it, and then we can write sin omega t naught plus theta g by 2. So this becomes the average of the RF input signal. So for finding out the v of t1, the velocity at the time of exit here, so for this we will modify the first equation, v of, this is v of t naught, we can say is equal to v naught, but if we want to have that v of t1, then in place of this v naught we will be placing v naught plus average value of the RF input signal vs. So by this we can find the v of t1. Here we have written it, that is vs. Here we have written v of t1 is equal to square root of 2 e by m into v naught plus average value of RF input signal. So vs we have written. Now this value v of t1 is equal to, now we can calculate. So square root 2 e by v naught we can take out, so it will be 2 e v naught divided by m whereas in place of Vs we are placing the value, that is this of V1 beta I sin omega t naught plus theta g by 2, and this V naught will be written in denominator as we have taken it outside from this bracket. And this value you are knowing that square root of 2e V naught by m in the first equation, as we have seen, that is nothing but the velocity at time of t naught. So V naught we can write, and here it becomes, this equation becomes, that is V of t1 square root of 2 ev naught divided by m is equal to 1 plus beta I v1 v naught sin omega t naught plus theta g by 2 in bracket to the power 1 by 2. 1 by 2 as it is in the square root, that's why we have taken it in 1 by 2, square root 1 by 2. And now we can have the simplification by the binomial expansion. So binomial expansion states statements you are knowing. So for two terms we will be seeing, and higher order terms we are neglecting. So we are writing it here, V of t1 is equal to V naught. In bracket we have written that 1 plus beta I, as it is written it here, beta I v1 divided by v naught, but this power 1 by 2 will be taken it and written it here. And that is if it is assumed to be n, then we can write n beta I v1 divided by v naught. So n is equal to 1 by 2, we can write it here, beta I v1 divided by 2 sin omega t naught plus theta g by 2. And here if you see it here, that is V of t1, finally we have written V of t1 is equal to V naught into 1 plus beta I v1 divided by 2 V naught into sin of omega t1 minus theta g by 2. So this is the velocity at the time of exit from the puncture cavity, and this is the equation of velocity modulation. So this expression is the expression for velocity modulation, expression for velocity modulation. You can write it. So in the next lecture we will use it, and that next lecture will be of